Awesome. Welcome, everybody. We're here to listen to Josh tell us a little bit about Spring Boot and how it can help us in getting faster to production and kind of solving the right problems on the way. Give a warm welcome to Josh.
Awkward.
Take that in the meantime.
Well, hi, everybody. Hold on, we're having technical difficulties.
Right now.
Marco,
Yep.
Can you hear me now?
Yep.
All righty, good stuff. Thank you. Good afternoon, everybody. How are you? Oh, that's pathetic. How are you? Okay, good. Good stuff. Hot sauce. Well, thanks for coming to my talk. I appreciate that there are lots of better choices, really. But I'm glad you could come here. We've only got 50 short minutes together, so I'm going to do my best to go as fast as I can. We're going to look at a lot of code. I think code's very important. I think code is one of the few distinguishing things that we as programmers and developers and architects and technologists can really do to change the world. So I love code. I start with code. And besides, would you want to go to a code conference and not look at code? That would be weird. So before we get started, while you're taking note of that GitHub URL where I'm going to keep all the code, I want you to all please say fika. My favorite thing while I take a photo. Here we go. 1, 2. Oh, that's so good. Nope. And right side now. That's money. Good stuff. Thank you. Tak. Right. So, a little bit about me. I'm on the internet. My name is Josh Long. I'm on the inner tubes. How many of you are on Twitter? Twitter. It's 2016. Twitter. How many of you are on Twitter? All right. Awkward. What about email? Email. All right. Well, if you're on either of those social networks, as the kids call it, then don't hesitate to find me. I'm there. I'm here for you. I want to hear from you. I'm forever at your service. My name is Josh Long. I'm a Spring Developer Advocate at Pivotal. I'm also a recently titled Java Champion, one of my proudest achievements. I'm the leading contributor of bugs to projects like Spring Boot, Spring Cloud, Spring Integration, Vaadin, Activiti, etc. And I'm also an author. I've got now 5 books, almost 5 books, 4.5. The 5th one is still in process. That's Cloud Native Java. And for those of you who are wondering, I know you are, that's a blue-eared kingfisher from the Javanesian islands. So it's a bird. It's in the clouds. Java. Never mind. It'll come. It'll come. Don't worry. And then videos as well. So I'm out there spending a lot of time helping community, customers, users, etc., really come to grips with this new architecture, this new opportunity that we have. It's part of what I do at Pivotal. So how many of you have heard of Pivotal? Pivotal. We're a startup. We're a new company. We started in April of 2013. We're also the home of the Spring team, right, and also other technologies. How many of you have heard of Tomcat? Tomcat. Right. Well, OK. What about RabbitMQ? RabbitMQ. Good stuff. So lots of open source technologies under one roof. And we love open source. It's a big part of, it's actually everything that we do. It's in our DNA. We believe that open source is one of the key ingredients for communities to build something interesting very quickly. And we believe that helps them go faster, right? That's what we care about, is agility. We care about how quickly a user can go from concept to production. And we've seen lots of different organizations struggling with the same thing. We see them struggling to go faster, safer, from concept, from inception to production. Organizations are struggling with this use case. How do I get my software into production more efficiently? And they're looking for ways to move the idea through the software factory that they have in their organization, from concept to development to from product management to user experience to development to testing to the various administrators, and then off into production. How do you get that loop to go faster? And so there's there's a lot of different ways to do this. One is to remove steps in the process, right? So we see so-called feature teams. There's also cloud computing that helps remove some of the steps at the end. It automates it, right? But we also need to have the ability to stand up software and new services very, very quickly. We need small batches of work. And when we talk about small batches of work today, usually we're talking about microservices, right? So organizations are moving to microservices because it gives them the ability to deliver just a small thing, a small app, a singly focused thing, and then move that through the process. But there's a lot of non-functional requirements, things that you need to address in order to stand up new applications, in order to have velocity. And so while we've built Spring Boot to be a great way to build applications on the tried and true JVM, we've also optimized it, we've opinionated it, right? And that opinion is that production is awesome, right? So what we're going to talk about today is how to build an application with Spring Boot, how to do the kitchen sink. You're not going to use everything we're going to talk about here today. I won't even use everything that I'm going to talk about here today. But we'll see a lot of different things, and hopefully you'll get an appreciation for what's possible. So how many of you have heard of Spring Boot before? Spring Boot. All right, good stuff. It's going to be big. I've got a feeling about this Spring Boot thing. Right now, it's only 2.2 million unique downloads a month, which is to say, not all 8-point-something billion people on the planet. So we've got a ways to go. We've got a ways to go. Now, let's see. That was the other slide for that other talk. I worked very hard on those slides. Did you like them? That's all three of them. Those are epic. I think we can agree on that. So we're going to start our journey today, building a brand new application. And the goal, as I say, is to really just see how these things fly together. We're not going to spend too much time on the details, right? You can go off and read the documentation for the details. What I want you to see is just how easy this stuff works. So we're going to go to start.spring.io, right? Start.spring.io is my second favorite place on the internet after production. So production, then start.spring.io. If you are restless, unable to sleep, start.spring.io. If you want for inspiration on an otherwise doldrum day, start.spring.io. If you suffer from indigestion and seek relief, start.spring.io. If your children can't sleep, start.spring.io. It's, as I say, my second favorite place on the web. And what we're going to do is we're going to use this to start our journey with Spring. We're going to build a new service. I'm going to call it a reservation service. And we're just going to go ahead and take advantage of a lot of different stuff. So we're going to build a nonsensically trivial domain model. We use H2 for an in-memory embedded database. We'll use JPA because I make poor life decisions. So JPA. We'll use REST repositories as well. We'll add that. We're going to add Actuator for operations support. We'll add Vaadin, which is a user interface. We're going to add Timeleaf, which is a templating technology. We'll add web support, just basic Spring MVC and so on. We'll add the remote shell. Okay. What else do we want to add? I guess we can add the HAL browser. We can add, I don't know. Let's see what else we can go shopping for, basically. We can go down here and browse the catalog of different technologies. So there's a lot of different workloads, a lot of different features that we want to support. These are delivered as auto configurations. These are checkboxes that you see here. So while we are not covering anything close to the full extent of what's possible, you can see that there's a lot of options, right? We've chosen JPA, but of course that's just one of many great technologies. There's all manner of other stuff. And indeed, if you think about the logical progression of this, it ends up in some place called Spring Cloud. And a lot of this is actually Spring Cloud services that are delivered here. So Kafka and Zipkin and all the Netflix stack and lots of cluster management and all this stuff with the Zookeeper and Hazelcast and so on, right? Lots of different stuff above and beyond what we're going to talk about today. I've also given us the chance to make some decisions. So again, up here you have two choices, a Maven project or a Gradle project. You can use any other tool as well. We don't really care. These are just the ones that we have nice, simple code generation for, so there's that. Down here, you have choices about the package, of course. You've got choices about the Java version. Don't choose one of these if you can avoid it. It'll work fine, but they're end-of-lifed from, save for the security update. So you're at the mercy of Oracle on how well they're going to work. And since they are end-of-lifed, starting a new project today would be irresponsible. Start on 1.8. Give yourself the chance to have some happiness in your life. I'm a big fan. Also, Java or Groovy, both fine languages. Expect to see more languages in this dropdown coming soon. I'll stick with Java because that's pretty awesome sauce. We also have one last very unimportant choice to focus on. Jar or war. Now, if by some accident of physics, you're stuck in the very distant past, very, very distant past, like 2013, unable to move forward into the future, which is really just today, so it's nothing to be excited about or proud about, really. You didn't time travel, you're just where everybody else is. Then choose .war. But if you're here with me today, in 2016, then choose .jar. This is a big part of my personal, and I think also, if I may take a leap of faith here, I think it's also part of a very Scandinavian philosophy of make jar, not war. You have options, you have choices. I want you to do what's best for you, okay? It's just that there are choices here. I would leave the defaults. It's fine. It's good stuff. All right, I'm going to hit generate. Go, go, go. Oh, row. Conflict. Goodbye. Here we go. Take two, this time with more gusto. Here we are. Open this up. And again, I'm going to open up an IDE. This is IntelliJ. You can use whatever you like. How many of you are using Eclipse? Eclipse. Good stuff. Well done. Good stuff. What about NetBeans? Sir, are you here? Sir? Are you here? So NetBeans works perfectly. No, there's actually no reason not to use it. It's a great IDE. Actually, there's a great blog on Oracle just recently on using Spring Boot with NetBeans. So there's that. All right. So now I've got my Maven build, and you can see I've got just a bunch of starter dependencies. These are starter dependencies. They correspond to each checkbox that we've selected on start.spring.io. You can see here that these dependencies don't actually have any code. They just bring in other dependencies. Spring Boot itself only implies 2 jars worth of code. Everything else is just dependencies that have been level set and managed for you. So if you go up to our parent build, which by the by is completely optional, if you go to the parent build, you can see we've spent a lot of time managing the versions of common ecosystem dependencies, not the least of which are, of course, the Spring projects, but also things like the commons, Apache Commons, various libraries, and Derby, and CrashHub, and Flyway, and Liquibase, and Elasticsearch, and H2, and all the Hibernate stuff, and just all sorts of good stuff managed there. If you want to override the versions, of course, it's just standard Maven, so go ahead and either make the dependency provided scope or override the property. In fact, if you just want to override the version and you have the same artifact and group, you can redefine the property in your own build. Or just exclude. I mean, you don't even have to use these. All these do is bring in dependencies. We've got people on the Spring Boot team that have spent a lot of time playing whack-a-mole to manage these versions for you, so you don't have to worry about it. We have people with no hair, gone, just completely bald as the day is long. They have solved this problem for you. Each one of these dependencies, hello. Each one of these dependencies is opinionated, as I say. So if you want to get started today in 2016 with JPA, you bring in Spring Boot Starter Data JPA. That'll bring in everything you're likely to need to be productive with JPA today, including the latest and greatest Hibernate, and including the latest and greatest Spring Data support, and Spring JPA ORM support, and transaction support, and JDBC support, and a connection pool, which is, by the by, defaulted to Commons. I'm sorry, the Apache Tomcat DBCP, but you can also use Hikari CP or Commons DBCP or whatever you want, right? So lots of opinions, hopefully optimized for the 80% case, but easily overrided. And other than that, you have here, hello computer, Why are we unhappy? Spring Boot starter data X. X. Computer. Okay, just had to give it a push. So, other than that, we have a stock standard public static void main entry point, into our code. This annotation is a meta annotation. It actually, in turn, has 3 other annotations. So there's @component_scan and @configuration. This tells Spring that this class and any other class that has @configuration on it is a class that provides bean definitions. It's just a way of telling Spring about the objects that you want it to wire up. Component_scan tells it to register any beans in this package or beneath it that have a Spring stereotype annotation. So @rest controller, @component, @service, etc. These are all stereotype annotations. They get picked up automatically. The magic one, the one that is part of Spring Boot, is @enable auto configuration. And I'm just going to go ahead and tell you, us friends here today, between us, I personally didn't really like that name. I really thought that we could have done a better job. And I don't mean to air my dirty laundry, I really just wanted to make it, I want to go home early. But nobody listens to me. Nobody listens to me. So that's fine. So whatever. We got what we got. We can't change the past. So now there's also, of course, a unit test. There is no checkbox on start.spring.io for the unit testing support. We're going to add that no matter what, because it is 2016. Now, we're going to build a nonsensically trivial application. I'm going to build something using JPA, a JPA entity of type reservation. A reservation is just a nonsensical sort of, I want to go to some place, I want to put my name on a list. I don't know. Let's not dwell too long on the details of what this domain model is supposed to do or why or even how. Who cares? Instead, let's just write some code. So private long ID, naturally this is going to be a JPA ID annotation and a surrogate primary key auto-incrementing value, so I'll use generated value. I'm going to create a field called reservation name. Boy, I am having a lot of fun typing at a strange angle. I'm typing upwards. And I'm going to create some getters, because Java, right? So more constructors, because of object-oriented programming. More constructors, because of JPA, right? So why JPA? Why? Okay. ToString, because good form. I'll add an @entity annotation. There we are. So now I've got a basic JPA entity. That's a lot of code, but that is by far the most code we're going to write today, so don't you worry. We need some way of managing the data to actually talk to the persistence tier. If you've ever read Dr. Eric Evans' amazing tome, Domain-Driven Design, you know about the repository pattern, right? The repository is just an object that's in between your persistence tier. Oh, sweet nectar. Abracadabra. We're disconnected. Oh, thank you. Oh, I didn't even know that was an option. Good stuff. Thank you, Tuck. So, can we all see? Yeah, maybe. Good. Right. So now I'm going to create a very simple repository. I'm going to use Spring Data. Now, Spring Data has a concept of repository, but remember, repositories are boring code. They're undifferentiated heavy lifting, as Adrian Cockcroft likes to say. These are things that will not get you a promotion. Nobody's gonna approach you after work, put their hand on your shoulder and say, well done. Way to write the best darned select all from foo where ID equals whatever query ever, right? It's just dumb code. Don't write it. Don't even, you should slap somebody who asks you to write it. It's boring code. The machine can do it. If you close your eyes and kind of squint at the method definition, you can probably even imagine the query. And if it has no creativity involved, then you shouldn't be doing it. So what we like to do is to let the machine do it. We're going to do a declarative repository, sort of borrowing an idea from the Ruby on Rails finder methods world. So we're going to say collection of reservation, find by reservation name string rn, right? And that's going to turn into a query that, based on convention, will be more or less equivalent to select all from reservations where reservation name equals rn. Of course, you can annotate that with @query and so on, override that. Remember, this is not about one API to rule them all. You have abstractions. You have repository implementations for Couchbase, for Cassandra, for Neo4j, for MongoDB, for Redis, for all manner of other supported Spring Data projects. the goal here is just to make short work of the tedious CRUD style stuff, right? So that's fine. I've got a very simple repository now. You can see that the JPA repository has find all, sort, delete, flush, all these kind of common CRUD style things. There's also support for paging and sorting. But remember, that's not ubiquitous. You're not going to be able to go to a Cassandra, for example, and do paging and sorting. It's not a natural thing to do there. You won't see paging and sorting methods in that repository, for example. Conversely, you can also define custom finder methods, like this one here, right? I can also use more advanced features. So for example, if I'm using a Couchbase or a MongoDB, I can add geographical GIS queries. I can say find by location near, and then pass in a Spring data point or a box, right? So lots of good stuff there. Now we need some data. We need something to play with during the talk. So I'm going to create a component. And this is just, again, a stereotype annotation. I'm going to say dummy CLR implements command line runner. And this command line runner interface is just a callback. It's a callback that Spring Boot knows about. Whenever you see this void run method, in this interface, Spring will call that method, passing in the public static void main string variadic array from your main method. So that's nice because now you don't have to add all this extra junk in your main method just to get access to these arguments, right? So if you want to do batch or ETL or anything like that, create a bean, annotate it with that. In our case, it's also nice because we can use it to inject. We can say @autowired, private reservation repository. There's that. We can say, let's see, stream dot of. There's Matthias, of course. Me, Phil. I need some names, friends. Wait, I learned one the other day. Inga, is that right? Is that a name? Is that okay? I need some more names, friends. I need just 10 more. What is it? How do you spell it? Okay. A-N-E-E. Ooh, like that? Nice. Okay. And that's not sweet. Is that like, I want to typically Swedish. Okay, fine. Richard, you win. Victor, thank you. Oh, Victor. I got to talk to my friend Victor. He's here somewhere. Good. Okay, so for each name, we're going to call the consumer here. We're going to use Java 8 lambdas. How many of you have had the pleasure of using Java 8? Java 8. Oh, go home and slap your boss. Make sure you can get Java 8. It's awesome. I love Java 8. I mean, don't actually slap your boss, but demand Java 8. It's for like your bonus or something. Just say, I'll take a little off. I want Java 8. So reservation repository.save, new reservation, passing in the name. So I'm just saying for each record in that collection, call the name, call this consumer, pass in the name, and let me do something in it interesting. And then I'll go ahead and call every record that I get back from the database and have Java call the system.out.println function reference, right? And if you look at what I'm doing, I've got a whole object here just for the ceremony of having a method in this case, get called when the application starts up. This is fine, but it's a lot of extra work. I really think that we should take advantage of this feature, lambdas, which is, as we've all, I'm sure, been made aware, one of the most modern, unique individual features of Java, a feature that only other very modern languages have. Languages like C, COBOL, Lisp, Smalltalk, PHP, JavaScript, Forth, Haskell, Visual Basic, Perl, Python, Ruby. Anything else? I mean, OCaml, Objective-C, C#, C++, F#, right? Haskell. I mean, only the modern languages that have come in the last 50 or 60 years have this feature. So it makes me very happy that we've added that 2 years ago. Now, because that feature is there, I can actually turn this very noisy distraction, this ceremony-riddled object, into just an anonymous bean. I can just say, I can tell Spring, instead of me creating a class and adding an annotation, I'm going to just give you a provider method. You take the return value and manage that instead. So we'll create the provider method like this, and we'll tell it to inject the collaborating object, the reservation repository, just as before in there. And then this just goes in there instead. So now I can say return args, return args, passing in providing a lambda, and that can get rid of this noisy class. Good stuff, right? Nice. So I've got my application. Let's go ahead and comment out some stuff for now, just for edification. So I've got Spring Boot starter JPA. leave almost everything else gone. And then that should do. We should be able to now start the application up and see our results. We should be able to confirm that when we've added the data to the database, that we can see the records we've just added. I'll drink some water. Okay. So there's the data in the database, right? It worked. Of course that worked. This is a demo. I don't make mistakes. I'm not sure what you were expecting. Instead, this is what I wanted to focus on. This is the ASCII artwork that Spring Boot provides. Now, this ASCII artwork is gorgeous. We have on the Spring Boot team several doctors, people with PhDs, people who in their previous lives worked with nuclear physics, star stuff. The very celestial bodies in the heavens above us were their daily bread and butter. So it makes me very happy to imagine that one day, somewhere, somehow, someplace, they got a GitHub issue saying, we need better ASCII artwork, and damn it, they did a good job. Look at that, right? Some people say to me, rather stupidly, can we get rid of the ASCII artwork? And it's at that point that I resist the urge to start flipping tables, because it's a dumb question. There's no way you could do a better job than this. However, since people do want to know, I'm going to go ahead and show you, okay? Sometimes you can replace the ASCII artwork. I don't recommend it. I don't really think most people could do a better job, right? So I'm going to go ahead and, just this one time, okay? I'll show you. So what I've done is I've added a banner TXT file to my source main resources. And again, only if you can do a credibly good job should you replace it. If you can't, then reconsider. Reconsider what you do. Now, that's fine. We've got good ASCII artwork. We've got data being we got data being written to the database. This is 2016, however, so if you write data to the database and you don't have a REST API, did you really write data to the database in the first place? Existential philosophical question. I'm sure we've all grappled with it in basic high school philosophy. In our case, the answer is no. So we're going to go ahead and build the REST API. I'm going to bring back Spring Boot Starter Web and Spring Boot Starter Data REST. And the goal here is just to stand up a very simple, nonsensically trivial REST API. Again, you can do this a couple of ways. We could, of course, take the long way home and say at REST controller, class, reservation, REST controller, like so. And we could say at autowired, and I'm going to inject the reservation repository. By the way, I should call out that I'm doing something terrible. Don't ever do this. I'm using field injection. That is to say, instead of satisfying the state of the object by passing in collaborators in the constructor, I'm passing in fields, which is a terrible thing to do, but I'm doing a demo here, friends. I don't have a lot of screen real estate. Do as I say, not as I do. So I'm going to go ahead and stand up an endpoint here. I'll say method equals get, value equals reservations. Nope, reservations, okay? And I'll just return the data. I'll say a collection of reservations, return this.reservation repository.find all. And there we go. That's a very simple REST API. That would work. You know, you get the JSON for each record. But that is a lot of extra code. We're in 2016. What I really want to do is map the business state transitions that my repository already knows how to handle to the appropriate HTTP verbs. That is, after all, the essence of REST. So I'll go ahead and do that. I'm going to let Spring Data REST do the heavy lifting here. I'll say at repository REST resource. And I'll annotate this. I'll say REST resource path equals by name. This is a finder method after all. I want to give it a nice sensible path. And I'll say that this is a param, okay, so rn. And then I'll restart. Here we are. Good stuff. Oh, it's so good. I mean, the ASCII artwork. The water's good too, though. All right, so localhost 8080 reservations for, there we go. So there's our data coming back from the service, right? Obviously, there's links. These are metadata links. These are an implementation of a design pattern called HotOS, hypermedia, as the engine of application state. It's the idea that every REST resource should have information enough for the client to be able to further manipulate that resource without any a priori knowledge. That is to say, self-describing APIs. Remember, as you move to a microservices world, you're going to stand up lots of different APIs, so it's sensible and decent to expose them in a humane way for humans, not just for robots, okay? These links tell you what you can do with the current entity given the state it's in. So, for example, if I scroll down, I can see there's links down here saying that if I wanted to do a search, I need only go to this endpoint here. Search, go away, dictionary. Seriously? If I wanted to do a search, we're going to have a talk later. Whatever. Search There's the search endpoint, yeah? And if I wanted to go to the search by name, I can say search by name, rn equals enders. There we are. So there's the query, yeah, and I get the records and all that, and I can do all sorts of things. I get this all for free, right? And it responds, of course, to paging and sizing, and it also knows what to do with post versus delete versus whatever. So you get a lot of really, really nice things here. You also get links here telling you which page you're looking at in the result set. So very, very sensible. But of course, this wouldn't be much of a demo if I didn't build a web application. So I'm going to go back to my build here, pom.xml, and I'm going to go ahead and bring back Spring Boot Starter Timeleaf. Now, Timeleaf is a templating technology. How many of you have heard of Timeleaf? It's a templating technology. It's very nice. It was developed by people in the Spring ecosystem. We like it. So you can use other ones. You can use Velocity. You can use FreeMarker. You can use Mustache. You can use Groovy server pages. You could even use, but don't. You could even use, and I mean it, don't. You could even use JSP. Now, don't. So we're going to use Timeleaf, and we're going to stand up a basic Spring MVC REST, or MVC controller here, right? So I'll say at controller. This is the classic Spring MVC, the one that's been around, whereas all of it's Spring MVC, but this is the one people might know about. And we're going to say reservation MVC controller, and we're going to create a URL. And again, this is a demo. This is a demo, so I'm going to use a strawman URL that doesn't actually correspond to something I would ever do in production, ever. Okay, so something like reservations.php. Now, again, choose what works for you. Okay, I'm going to inject a model here. This is a glorified key value map, and it's a good place for me to insert attributes that I want to be able to dereference from my template, the template that I'm going to render. I'm going to inject a collaborator here, the reservation repository, and I'll say reservation repository.find all. I'm going to store that in the model. I'll say model.add attribute reservations. There you go. So that's just a collection of all the data, and it's going to be available for the template, which is going to be resolved by a view resolver. By default, it's going to look for source, main, resources, templates, x.html. Right? That's the Timeleaf heuristic. So I'm going to go ahead and copy my template in there. See, copy desktop, reservations, downloads, reservation service, source, main, resources, templates. Whew. Having fun all the way. Okay, so there's my template. It's pretty simple. You can see this is actually sort of like a server-side Angular, in that it's round-trippable. Have you ever had that experience where you give a server-side template or any kind of template to the graphics designers on the team, and then they leave a bag of flaming poop at your desk? Is that, what I'm talking about? Just me? Okay, well, never mind. So JSP creates that problem. Timeleaf gets rid of it, right? Because they can actually open this up and preview it in their tools. So let's see, that's fine. That's one way to go. We can start with that. Here we are. I'll drink some water. It's good stuff anyway. Did you guys hear that? Oh, so good. Merry Christmas. So, right, here we go. Localhost, reservations.php. Oh, wrong port. Haha. There we are. So there's my desperately simple HTML page, just to prove you could. I'm not a designer. Your mileage may vary. Don't hate. So, okay, that's one kind of user interface. That's certainly a good way to go. I am often in the situation where I like to throw together data-driven forms and grids and all that stuff, and I'm not really, as I've stressed, I hope, sufficiently. I'm not a designer, so sometimes it's just nice to let something else do that work for me. One of those technologies that's actually pretty great at this kind of stuff is Vaadin. How many of you have heard of Vaadin? Vaadin. So they've developed a really nifty auto configuration for Spring Boot. So I've got that brought back here. This is on the class path. Com Vaadin Spring Boot Starter. That's on the class path here. And so I can go ahead and use that as well. I can say Spring UI path equals UI, and I'll say at theme equals Valo, which is, I'm not sure what that means, but it means something interesting. Reservation UI extends UI, and I'm going to call the init method because I should init, and then inside that I'm going to create a grid that'll contain some data, just a simple table, passing in a new bean item container whose type is of type reservation.class, and I'm going to inject a collaborator just as I did before, right? This is the @AutoWired private reservation repository, okay? And I'll say this .reservation repository .find all. There we go. I'll say I want the component to be full-sized, right? So this is, again, a component-oriented framework. It gets transpiled to JavaScript thanks to Google Web Toolkit, GWT. So there's that, and I'll say set content equals grid, and there we are. Now that's a very simple user interface. I don't know much about web apps, so that's fine enough for me. One thing I want to do is, we should have done this in the beginning. I want to move my reservation entity to a public type. That's one of the few things that really in all this code should have been and could have been public, right? Everything else, you'll notice I'm just typing in the same package because it's all really component code. It's not going to be exported or shared to anybody else. So now I'll restart. Good ASCII artwork in hand. Visiting my browser here. Hello. Okay. So there's that, of course. Now I should be able to go to UI, and there we go. I get this fancy schmancy JavaScript grid with a table and sorting and all this stuff. I'm not really sure how it does all that sorcery, but it works. It's slick and clean, and you can get something thrown together, right? So that's an application. We've got a very simple application with a web application, using Spring MVC, and we're also using Vaadin, and we've got data talking to the database, managing transactions. We've got a REST API. We've got not just a little bit of stuff for the time. Now, I talk about production. I love production. So could I deploy this to production? Probably not. There are some non-functional requirements that operations teams, hopefully that's the same team as the developers, but either way, the people that represent those use cases, would balk at, right? The lack of those would be something worth balking at. So we need to address those. I'm going to reinstate the Spring Boot actuator, right? So actuator, and again, I'm not a physicist. I'm not really sure, but the Spring Boot actuator, as I understand it, in my layman's view, is sort of the Bruce Lee one-inch punch for physics. It turns a little bit of energy into a lot. And the idea is that this is going to help you get your application to production quicker. It's going to take care of those non-functional requirements that are, as we said before, undifferentiated heavy lifting, things that nobody's going to pay you more to do a good job on. How many of you have ever written a health check, for example? Was it exciting? Did you stay up all night, like ignoring your family for it? Anybody? No? Yeah, I didn't think so. It's not exciting code. Nobody gets passionate about writing the best darn health check possible, right? So things like that, right? So we're going to look at that. We've got now our application. Here's the user interface. We can go to reservations. I'll go to reservations 1 and 2, and just go to the search endpoint here. Okay. Enders. Okay. So I've got data that I'm searching for. Now, having done that, I can go to / and I can see if I go to / metrics, I can see some very interesting, albeit default information about the system. I can see here, for example, that I have so much memory, and so many processors, and so much heap, etc. Right? So this is all just sort of interesting information about the state of the application. I can also see, if I scroll down just a wee bit, that I've made 9 requests to something, / reservations. Oh, sorry, wrong one. If I've made 2 requests to / reservations / ID, got a status code of 200. I made 2 requests to / UI, got a status code of 200, etc. I can add custom metrics as well. This is very important because operations care about not just collecting data, but understanding it. So if I want to create semantic metrics, things like, is the system up and running? Is it how many orders have been added? How many customers have checked out? Whatever. I can emit those metrics and collect them here. Even better, if you have the Dropwizard metrics library on the class path, which is a great library, by the by, you can use its support for histograms. You can emit custom metrics that start with meter, and those metrics will be shown. You'll get the first percentile, the mean, median, max, the 95th percentile, the 99th percentile, etc. Very useful information because point-in-time numbers, while interesting, don't tell a story. What does a number mean relative to the average performance of the system? That's more interesting, right? So you need to see that. So add that support, and this will automatically work with that. You can also export all of this stuff. So for example, if using Graphite or InfluxDB or OpenTSDB or whatever, all of this gets exported. You can configure a metrics writer on there. I'm going to go to env. Now env shows an enumeration of the system properties and the system environment, right? These are interesting for debugging the discrepancies between one application's environment and another. If I go to mappings, mappings gives me an enumeration of all the endpoints that have been exposed to HTTP traffic. and the components that handle them, and whatever else we can discern automatically. So for example, the error endpoint produces text HTML, and it's processed by this Spring Java component here, right? If I go to trace, this gives me a limited to 100, by the way, by default, request log, right? It shows me all the logs of requests that have flown through the app, the timestamps, the verbs, the endpoints, the headers, and the response headers, and so on. So of course you can write this out to something more durable. You can delete, you can remove it, etc. But very useful for operation information. Another one that's interesting in that it's empty is info. Info is an ideal place using basic Maven resource filtering, and you can see that in the docs, to add things like the service version ID and the artifact ID and the group ID, right? If you want to correlate which version of the system is running in production, you need to have something like that stood up, and that's very simple. And of course, there's the health endpoint. Now the health tells us basic things that we can automatically infer from the environment, from the application. We can see that we've got a file system, so here's how much disk space we've got. We've got a database, and so here's how much of the, here's the status of the database, here's the connection pool, select one from dual or something like that, the validation query. So all of that is well and good, but I want to be able to customize it. So I'm going to go back to my application.properties. First thing I want to do is I probably want to move these things into a separate context path, right? So I'm going to say management.context path equals admin. That'll prefix it, right? So now, if you're using Eclipse or Spring Tool Suite or IntelliJ, those properties are auto-completable. They're driven by a runtime component that Spring Boot provides in the framework. They correspond to things that Spring Boot itself knows about. So all these properties, all these well-known properties, you can do all manner of things. Like I can set the endpoints up. I can say server.port equals 8000, for example. I may want to say management.port is 9000, right? So management.port is 9000. Now I've moved the ports to 9000 and to /admin. Let's just keep it simple like this for now. So that's one thing. I also want to contribute my own health indicator, right? I want to override that, providing my own specific perspective on the health. So I'll say health indicator, return new health indicator. And again, you can see that Spring Boot has a lot of different health indicators for Cassandra, for Java Mail, for JMS, for Mongo, for Elasticsearch, for whatever. But I want to contribute my own. So I'm going to say, instead of saying health.down or out of service or up, I'll just say status focus.build, okay? And naturally, this lends itself to a Lambda, so there's that. And I'll restart. Here we go. Come on, computer. Drink some water. So now, when we start the application up, this won't work, of course, right? It's not on port 880. It's now on 8000. And even if I did do that, that won't work either because it's now contextualized under admin, right? So I've had to change those things, and now I can see my custom health indicator there as well. This is only one of many views on this data, though, of course. So I may, for example, want to access this information from JMX, which is already supported. I can also, if I add the remote shell, Spring Boot starter remote shell, I can also access this information from the SSH crash hub shell. So I'll restart that with that in the class path. And what that'll do is it'll give us a default username, absent specific Spring security configuration. It'll give us a username and a default password. So I'm going to restart, because I think I restarted it before it could see the new dependency. There we are. So there we go. So that's absent Spring security integration. If I had configured it to talk to LDAP or PAM or Kerberos or whatever, it would have used that. But absent that, it's just given us a default user and password. So here I'm going to say SSH -p 2000 user at 127.0.0.1. Paste, and there we go. And now we can ask some questions. Help. Metrics, for example. Shows me the metrics. These are live. I'm not touching anything to get them to animate, to update. My favorite perspective in here is dashboard. Dashboard gives you a running enumeration of all the threads in the application, as well as all the memory pools in the application, right? So we're really trying to make it easy to get a visibility into what the system is doing at all times. Now, you may say that that's well and good, but I need to deploy this actually, right? I need to actually get to production, and there's a lot of stuff involved in moving applications to production, and that's a good point. So what I'm going to go do is I'm going to make my Spring Boot app executable, right? So it's already Java -jar-able, but I want to make it executable. So here we go. I'm going to say executable equals true. And I'm going to kill this, and I'm going to go to the command line here. And let's see, downloads reservation service. If I do maven -d skip tests, because I'm short on time here, friends. Okay, I'm going to try and generate a jar. Here we go, cd target, du -hs, reservation jar, right? So that's my 58 megabyte jar. That includes Tomcat. You can use Jetty or Undertow if you like. It includes an SSH server. It includes JMX. It includes all of Hibernate. It includes the various Spring bits. It includes Tomcat, right? Like I said. So that's everything. And that's very convenient because now I can take that jar, chuck it in an email as an attachment, and my grandpa, who's got applets, he can run it, which is good, right? So if your operations team can't run this, you can. And I checked Swedish law. I'm pretty sure that you can fire them if they can't run it, right? I'm just saying. I'm pretty sure. So because grandpa can run it, surely they can run it, right? So you say java -jar and you get the application. But I want to override certain things, right? I want to override, for example, the port, and I don't want to have to recompile my application just to be able to see the difference, right? So I can override things by saying java -d server.port equals 8010, for example, -jar reservation service.jar, right? And so what that'll do is you'll see it spin up on port, what did we say, 8010 down here? There it is on port 8010. But maybe I don't want to do that. Maybe I want to use environment variables like with like Cloud Foundry or Heroku or Docker. So I can say export server _ port equals 8020 java -jar reservation service.jar, right? And that'll override that. So any property that we can use in that application.properties, I can use here. One thing that's really nice, and I have a question. How many of you know how the JVM reads jars? Do you think it reads from the top down or the bottom up? Bottom up, somebody said that? You're absolutely right. And that creates a little bit of a discrepancy because your average operating system reads from the top down, which is great. So now we can do some sorcery. So check this out. These are actually executable jars. So I'm going to do this. Right? Did you see that? No java -jar. Even better, if you look at the code of the jar, there's a shell script in there. Shell script, 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 bytecode. And the shell script knows how to respond to initd and systemd lifecycle checks, so status and stop and start, and it manages PIDs, it does all that stuff. So you can take this jar, drop it in your initd directory, and it's done. The operating system will start it up. It'll get destroyed when it goes down. All the lifecycle management is taken care of for you, right? And it'll do things like, it is your start script. It does it all for you. So you get a lot of power there, right? This is all part of what we're trying to help people get to, is that a big part of building an application is getting to production quickly. The way this works is thanks to the magic of something called Spring.Factories, which is a text file that you can put in your own jars, in your own code as well. It's a text file that has one little line in it that we care about, org spring framework boot enable auto configuration. And if you look, for example, at rabbit auto configuration, you can see here that it's just a Java configuration class, as we saw earlier, that has various bean definitions, just like the command line runner and the health indicator. These definitions get provided by the runtime, but we don't want them to be provided if it's not appropriate. So for example, we have a conditional that says, don't create this rabbit auto configuration, don't create these beans specific to RabbitMQ if we don't have the type called rabbit template on the class path. Similarly, don't do it if we don't have the channel type. We can also say, don't create this bean if the user, that's you or I, has already provided a bean of type AMQP-admin. This makes it so that we can do very dynamic things. As we added libraries to the class path, we got new features. You saw that, right? As I added Spring Boot Start a Web, we got a Tomcat suddenly. No configuration. And if you want to make it so that building a new application is easy and consistent, you can build your own auto-config, your own auto-configuration class. Make sure you standardize on, make your security and your configuration and whatever work the same way in your auto-config, and you get consistency and velocity. So with that, my friends, I think we're kind of at the end of our little journey. I'm really, really sorry we didn't get to cover much. I feel like perhaps next time, maybe we could do a little bit more. What do you say? Yeah? What do you think? Yes? Would you use something like a Spring Boot in your world? Okay, good stuff. I want to thank you so, so much for having me. It's been an honor. Tak, thank you so much. Cheers, guys. And I'll take questions off stage, I guess.